Hi Pre-Calc kids, these are your 1.2 exponents and radical notes. By the way, I think it's probably going to be a good idea to just take the notes probably first and then listen to the video at the end and you can kind of walk through. But it's probably going to be pretty tough to write on this one. There's going to be a little bit longer notes. So for the first one, basically anything to the 0 power is always going to be 1. That's just a rule you're going to have to remember. We can talk about why it happens later, but just remember anything to the 0 power is 1. And then negative exponents flip whatever it is that's to that power to the bottom of the fraction, or later on if they're on the bottom it's going to flip back up. So for instance, x to the negative first is 1 over x, and there's a little positive 1 even though you can't see it. Or negative 2, which is just a number, raised to a negative power, flips down to the bottom. Notice that the 3 becomes positive, but the negative 2 stays negative. And then negative 2 cubed is negative 8. So we get the negative 1/8 there. The side notes over here, anything to the 0 power is 1, negative powers flip. You probably remember these a little bit better, just the rules. If we have the same base and we're multiplying, we're going to add the exponents. So 4 plus 7 is 11. Same base, we're multiplying, so we add. If we have division, we subtract. If we have a power of a power, so b to the 4th raised to the 5th power, we multiply those together and get b to the 20th. Here, when we have a power of power and there's more things in there, then we've got to distribute that power to everything in the parentheses, even the whole numbers. So 3 to the x cubed becomes 3 cubed x cubed. 3 cubed is 27, and x cubed stays itself. And then if we have a quotient, or division, we still distribute the powers to everything inside. So you have x to the 5th and 2 to the 5th, and 2 to the 5th is 32. Coming over to example 3, this is just a same type of problem, but using all of those rules at once. The first thing I did in this problem is distributed the 3rd power to the x and the y. You'll see that here. And then I distributed the 4th power to everything inside this parentheses. So y squared to the 4th is y to the 8th, x to the 4th, z to the 4th. And then on problems like this, I like to go across the top. Since this is multiplication, x cubed times x 4th is x to the 7th. And then y to the 8th doesn't have anything to go with. And then on the bottom, y cubed and z to the 4th can't be combined. But now that I have division, if I have y to the 8th on top and y to the 3rd on bottom, I can think of this as subtraction. 8 minus 3 is 5. I can also think if I have 8 on top and 3 of them are canceling, I'm going to have 5 left over on top. For example 4, another just more in-depth problem, whenever I have negative exponents, like t to the negative 4th or s to the negative 2, those just flip the thing that they're directly connected to. So notice this t to the negative 4th goes to the bottom, but only it went to the bottom. And then this s to the negative 2 is going to go up to the top, to the numerator, but only it moves. It doesn't move the number, it doesn't move anything else, just itself, just the thing the power is connected to. The 6 divided by 2 is 3, and then you can combine your s's. S times s squared is s cubed, t squared times 2 to the 4th is t to the 6th. The next couple of examples are sort of reminders about what to do with fractional exponents and roots. So if you haven't heard this before, there's the cowboy and the horse way of remembering this. The cowboy rides on top, the horse is on bottom, and then the root is like a house. And so at the end of the night, the cowboy gets to go inside the house, and the horse has to stay outside. Just a silly way to remember how to switch from fractional or rational exponents to roots. Now, once you get here, it's probably going to be easier to take the cube root of 8 first, because it's going to get small. The cube root of 8 is 2. And then you square it, and you get 4. If you see addition between roots, then you've got to break them down and get them to where they're the same root before you can add them together. So root 32 would break down as root 16 and root 2. The square root of 16 is 4. Root 200 breaks down as root 100 times root 2, and the square root of 100 is 10. Now that we have a common root, these are like terms, or you could think of it as factoring a square root of 2 out, and then you add 4 plus 10 to get 14 roots of 2. All right, this does it for tonight's notes. Like I said before, you're probably going to want to copy these down first and then re-listen to the video as a whole at the end, which I know might take a little bit longer. But hopefully this will help us streamline class a little bit tomorrow. Thanks, and have a good night.